Okay, welcome to Rocking Math and the segment on probability of composite experiments. The main idea is we want to be able to find the probability of independent and dependent events. Some vocabulary that we need to visit is composite experiment, independent events, and dependent events. And we're talking about standard 8.11, where the student applies concepts of theoretical and experimental probability to make prediction. We want to find the probability of dependent and independent events, and we want to use theoretical probabilities and experimental results to make predictions and decisions. Key concept here is, or should I say R, the probability of two independent events can be found by multiplying the probability of the first event by the probability of the second event. And we will use the symbol probability of A and B is equal to the probability of A times B. So all that's to say that we're going to look at two different events that occur totally independent of each other, and which means what one does has no effect on what the other does, and we're going to look at those and multiply. Now let's go back and make sure that we understand exactly what we're talking about. We said that from the beginning that we say that when we do something, any activity involving chance, such as spinning a wheel, flipping a coin, or rolling a die, is called an experiment. We also said that each repetition or observation of that experiment is called a trial, and each result of that trial is an outcome. So a set of one or more outcomes is called an event. Let's take an example. If we are rolling a 5, which is an outcome, or rolling an even number, which is more than one outcome, both can be identified as an event. So anytime we're looking at the probability of an event, first of all, we must understand that a probability is always denoted or written as a fraction, a ratio, a decimal, or a percent. And the probability is measured between 0 and 1. So the probability of an event is written as P parentheses whatever the event is. And we also need to know that when we look at these probabilities, that if the probability stands at 0, then it is pretty much impossible, and if it stands at 1, then it is pretty much 100% certain that it'll happen. And we have all of the decimals or fractions or percent that's in the middle, and the closer it gets to 1, the likely it is, and the further it goes from 1, the unlikely that it will actually happen. Okay, so we've had our little history of what probability and what we are trying to understand here. So let's take a look at working a problem and seeing exactly what this composite experiment is made of. Okay, so when we look at an experiment, we want to be able to know that we are comparing the number of times something will happen. So that means that our probability will be the actual number of times compared to the total number of times. So in our example below, it tells us that 2 spinners numbered between 1 and 9 and spun, actually are spun, and our chore is to determine what is the probability that both spinners will show a number greater than 6. Okay, so we need to think about, first of all, what is the total number of particular, so the total trials for the first, so let's just call this the first spinner, and then so we know that it is 9 because it says from 1 to 9. Well, from there we need to determine how many numbers are greater than 6. We would not include 6, but we know it would be 7, 8, and 9. So that gives us a 3 out of 9 chance of it happening. Well, let's go ahead and take a look at the second probability of the second spinner. And we're looking at, again, because there are 9 and it's the same 7, 8, and 9 greater than 6, we have a probability of 3 out of 9. But now, when we're working with these probabilities, let's take under the fact that we can simplify just like we were doing any normal fraction, and we can simplify by dividing by this particular case, dividing by 3, not all cases, but this one, and we can get 1 over 3, and we can do the same thing for the first one. We can divide by 3, and we can get 1 over 3. Now, if we go back and look at our symbol, or actually our key concept, it says when we are comparing, we look at the probability of A and B. So we've already got our problem set up. Now all we need to do is see how can we solve it. And we're talking about the probability of the first spinner. I'm just going to use that. Actually, I'm supposed to say a number greater than 6 and a number greater than 6. That would be the correct thing to do, but I'm going for time space. And the second, and we're looking for number greater than 6. So we see that we have the probability of 1/3 and again 1/3. We can take that and have the probability of 1/3, and that can be times the probability of 1/3. Okay, so once we get here, we multiply, and think about when we are multiplying. So I'm going to bring this out here so we can see it. So we got 1 over 3 times 1 over 3. Let's go back to our fraction rules of multiplication. It say when we multiply fractions, we multiply straight across, the numerator times numerator, and denominator times denominator. So once we do that, what we will get is we will get the probability for both spinners with numbers greater than 6 to be spun. We'll get a probability of 1 over 9. Then of course we can, if you want to divide, which is, we'll get it into a percentage for you, is you'll just take 1 and divide it by 9. So let's go ahead and put the decimal here, the decimal here. So that goes 1 time, and then that's 9, and one time again. So we're looking at 11.1%. Okay, so here it is a probability of 11.1% of that particular outcome happening, and we're talking about spinning, and both times we will spin, we will get a number greater than 6.